Hi everyone, my name is Obava, and my lab is on perfectly inelastic and elastic collision. First, we have to understand momentum, which is a quantity defined as the product of an object and its velocity. Basically, in simple terms, if an object is moving, it has a momentum because it's moving, which is velocity, and it is an object, which means it has mass. Mass times velocity equals momentum. This can be shown by the formula down below, highlighted in yellow. P equals m times v. V equals velocity measured in meters per second. M equals mass measured in kilograms. And P equals momentum, which is measured in kg meters per second. That is because both of them are combined, which means that it'll take both units of measurement. Now, if you look down to the bottom left, you can see the example that I gave, and we're going to pretend that it's a ball and it's going to roll to the left. Now, the ball is 5 kilograms and it's moving at the speed of 7 meters per second. Now, if we plug and chug this into our P equals m times v, we'll get P equals 5 kilograms times 7 meters per second. Now, if we multiply this together, we'll get P equals 35 kg meters per second to the left. So basically, the ball will roll to the left at 35 kilograms meters per second. Okay, moving on to perfectly inelastic collision is when both objects stick together after collision, and kinetic energy is transferred to sound and thermal energy. This can be shown when two balls are going towards each other and make a clicking sound as they collide, and both stand still. Kinetic energy is not conserved in perfectly inelastic collision, but momentum is conserved in perfectly inelastic collision. Now below is the long equation for perfectly inelastic collisions, which is demonstrated by the mass and velocity of two objects. Now, if you look down below, I highlighted which mass and which velocity belongs to each object. So everything in green belongs to object 1, and everything in yellow belongs to object 2. Now, reading this out is mass of the first object times initial velocity of the first object plus mass of the second object times initial velocity of the second object equals mass of the first object plus mass of the second object times final velocity of both objects as one mass after the collision. This is because when the objects collide, there is only one velocity for both of them. For my demonstration, I decided to use my sisters while they were playing at the park. One of them decided to take a break while the other snuck up from behind and pushed into her. Now this is a form of inelastic collision because, first of all, can we notice the difference in mass? The one standing still will have a greater mass than the one running, but the reason why the one running will have such a great force on the one standing is because of the momentum that she built when she was running. So if we look closely, momentum is being built up, then we have contact, and after contact, both will start to move. They're stuck together, both of them are moving, but it is slower than the initial velocity of the girl in blue. So we can watch this again. Velocity being built up, contact being made, both of them stuck together and moving at the same time, but it is just slower than the initial velocity. For elastic collision, it's kind of the same thing, just a little bit different. Again, elastic collision is when a collision occurs between two objects. The total kinetic energy of the two bodies remains the same in elastic collision, and the objects separate after collision. Now, this is different from the first one because obviously the objects are separated after the collision. Now, the long equation here again, we have it divided by colors. So we have, again, object number 1 is green and object number 2 is yellow. So I'll read this out loud. Mass of the object number 1 times initial velocity of object number 1 plus mass of object number 2 times initial velocity of object number 2 equals mass of object number 1 times final velocity of object number 1 plus mass of object number 2 times final velocity of object number 2. Now that's a long, very long way to read it, but basically it's pretty much the same except for the ending. Mass times final velocity plus mass times final velocity of two different objects. So they're going to have two different masses and two different velocities. Again, using my sisters, she's going to run into the one standing up, and she is going to fly forward while the one who initially started running will bounce backwards. Now, both will have different velocities. They're not moving at the same time. They're moving separately at different velocities, and they're separate, so that means that they will not have the same mass. And that's about it. Thank you guys so much for watching.